Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in to this video on expanding and factorising. We're going to do both in the one lesson because you're so smart. So expanding is actually something that you would have already done, and we expand brackets using the distributive law. So the distributive law is what we use when we have something like this, A outside of B plus C. So expanding is when you have brackets and you want to get rid of them. So we expand using the distributive law. And we call it the distributive law because we take what is outside the brackets and distribute it to everything inside. So we go A times B and then A times positive C. So that is the distributive law, what I've written just here. And that, again, is how you expand brackets. So the reason it works can be seen using some rectangles. So you can see that these two rectangles I put on your screen are exactly the same size and therefore would have the same area. So let's say I split the top one into two rectangles. So I'm going to call this width here A, and then I'll split up the length. So I have B here and C there. So A, B, and C stand for any random numbers, right? So the area of this top rectangle, well, I can find the area of this rectangle and then add the area of this rectangle, right? So the area of the red is just length and width multiplied together. The area of the black one is width and length multiplied together. And then I can just add those two, and that is the area of the whole big black rectangle, okay? So I would get the same area even if I didn't split up this rectangle. So note that I still have the width is A, but the length along here is just B plus C. So the area of this rectangle is just width and length multiplied together. So remember, if I'm timesing the width here by the length, I have to times this by all of this, okay? So this and this are both expressions of the area of the rectangle. Now, because the area of the rectangle is the same, because both rectangles are the same, then these two must be equal. And that's how we get our distributive law here. So let's look at some examples of expanding. Fortunately, it's very, very simple. So let's say we have something like this, 2 outside of x plus 3, and we're going to expand it. So we're going to start with something that has brackets and then get rid of the brackets. So we distribute the 2 to the x, and we distribute the 2 to the 3. So 2 times 3 is positive 6, okay? This and this are exactly the same thing. Let's say we had something like 3 times y minus 4. So same idea, 3 times y. 3 times, in this case, I'm not timesing it by 4, I'm timesing it by negative 4. So it'd be 3y minus 12. And hopefully you know that in each of these expressions, there's no like terms, so I can't simplify it any further. What if I had something like 4 times 2a plus 5b? Well, don't freak out, even though now we've got 2 letters and we've got terms with a letter and a pronumeral, we do it no differently. 4 times 2a, as we learned in the previous lesson, just multiply the coefficients, 4 times 5b. Okay, sometimes you'll have to do examples where you have to expand 2 brackets and collect like terms. So let's say I had something like this, 6 times 2x minus 1, plus 7 times 3x minus 4. So I'm going to expand each of these brackets and then collect like terms. So we'll do the first bracket first. 6 times 2x, 6 times negative 1, put the plus there. So we've got 7 times 3x, and 7 times negative 4. So note this and this are like terms. 12x and 21x are like terms. So 12x plus 21x is 33x. Minus 6 minus 28 is minus 34. Okay, and we're done. So I now just have to show you an example that's a little complicated. So I'm going to do it in red so you know how to look out for it. So let's say I had something like 10 minus 4 plus x. So people get confused when they have to expand something like this. So note, if there's just a minus and no number there, we can put like a 1 there. So we could put a 1 here and not change it. So to expand the bracket, so I'm leaving the 10 alone, I'm not doing anything with it. So minus 1 times 4 is minus 4. Minus 1 times x, so it's not plus x, it's negative x. And then 10 and 4 are, of course, like terms. I'm just left with 6 minus x. So make sure you watch out for those kind of examples. So pause and copy this down if you need, because we're going to start a new slide where we go through factorization. Okay, so we know from previous slides how to do things like 2 outside of x plus 3 in brackets. We know that's just 2x plus 6. They are the exact same expression. So when you start with brackets and then you end up with something that doesn't have brackets going this way, we call that expanding, and we do that using the distributive law, and that's what I've been explaining for the last few minutes. Probably seems like a few hours to you. So sometimes we want to go the other way. We want to start with something like this that doesn't have brackets, and we want to write it with brackets, and that's called factorizing. So when you factorize something, you write it as the product of factors. So you know, for example, I can write 36 as 9 times 4. They're the same thing. So I'm writing it as something times something, and that's what we're going to do with factorizing. So it's quite a bit more difficult than expanding, and it's probably something you wouldn't have done. So, how are we going to go about factorizing? So we're just going to follow 2 easy steps to factorize an expression. You write the HCF, which means highest common factor of all the terms outside the brackets, and then you divide each of the terms by that highest common factor, and you write the result in the brackets. So our example here, I'll just show you how if I started with 2x plus 6 and I factorize it, I'd get 2 outside of x plus 3. So this is one term, this is another term. Remember, terms are separated by plus or minus signs, like we did in a previous lesson. So the highest common factor of 2x and 6, the highest thing that goes into both is 2. So I'll write that outside the brackets. So 2x divided by 2 is x, 6 divided by 2 is positive 3. Okay, and then we're done. Let's say I have something like 3x minus 21. Okay, so the highest number that goes into 3x and also 21 is 3. 3 goes outside the brackets. So what do I times by 3 to get 3x? Just x. What do I times by 3 to get not positive but negative 21? Answer, negative 7. Okay, so the highest common factor won't always be the coefficient of x. So let's say, for example, we had 6x plus 15. Okay, so the highest common factor isn't 6, because 6 does not go into 15. The highest common factor here is actually 3. It's the highest thing that goes into 6x and 15. So we write highest common factor at the front. So what do I times by 3 to get 6x? 2x. What do I times by 3 to get positive 15? 5. Okay, so note that if I expand any of my answers, I should get what I originally started with. So you don't even need me, you don't need a calculator or anything to tell you if you're right. You can check that for yourself. So let's do a slightly more complicated example. So let's say we have 12ab plus 20b. Okay, so here the highest common factor doesn't always involve just numbers. So the highest number that goes into 12 and 20, well, that's not too hard, it's 4. But they also both have a b. b is also the common factor, and it needs to go outside the brackets. So now we go 12a divided by 4b, or if you like, what do I times by 4b to get 12ab? So you need to times by 3 to get the 12, and a to get the a. So 4b, what do I times that by to get 20b? So the answer again is just positive 5. So there should be no common factors with the terms inside the brackets. And 3 and 5, cool, they don't have common factors. So I know I've done something right. Okay, just be careful when there's a few negatives. So let's have something like minus 3xy plus 6x, okay? So here, the highest common factor, what we normally do is if this first term is negative, we take out a negative common factor. So the highest thing that goes into 3xy and 6x is 3x, but we usually take out a negative if the first term's negative, okay? And then we're just left with y. So if I put plus 2, like that, seems like it's right, but it doesn't work. Because negative 3x times positive 2 would give me negative 6x. So you've got to make sure you're very careful with negatives. So I'm going to rub that out, and it's actually y minus 2. And again, if I expand my answer, then I should get what I started with. So let's say I have negatives on both terms. Let's say I have minus 4z, and I have minus 10z squared. Okay, so highest common factor that goes into both. Well, 2 goes into both. I'm going to take out a negative 2 because the first term's negative. Z is also in both, so I'll write it there. So what do I times by negative 2z to get negative 4z? So it's positive 2 because you need to times a negative by a positive to get a negative. So what do I times by negative 2z to get negative 10z squared? And I apologize for my writing, that is actually a z. So minus 2 needs to be times by positive 5 to get up to negative 10, and you need to times z by z to get z squared. And this is my final answer here. So if I expand that, I get what I started with. All right, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.